Two boats go downstream from point X to point Y. Two boats go downstream from point X to point Y. The faster boat covers the distance from X to Y 1.5 times as fast as the slower boat. It is known that for every hour, the slower boat lags behind the faster boat by 8 km. However, if they go upstream, then the faster boat covers the same distance from Y to X in half the time as the slower boat. However, if they go upstream, the faster boat covers the distance from Y to X in half the time as the slower boat. Find the speed of the faster boat in still water. This problem is related to distance, speed, and time asked in quantitative aptitude for a lot of competitive exams. Seems to be a little bit tricky problem, so let's try to solve this. So we have downstream, upstream, boat, speed. So what are the speeds we have? We have speed of faster boat. Let us say that is x1 kilometer per hour. This is in still water we are talking about. Let us say speed of slower boat in still water is x2 kilometers per hour and speed of the stream is y kilometers per hour. And we have to understand that distance equals to speed into time. Whenever the distance is constant, then speed and time are inversely proportional. That means if the speed is 2 times, then time will be half of it. If speed is 1 by 2, then time will be twice. So that concept we understand, then it becomes very easy to solve this. Now when we look at upstream downstream problems, for downstream, for the faster boat it will be x1 plus y kilometers, and for the slower boat it will be x2 plus y kilometers per hour. Whereas upstream, faster boat will be x1 minus y kilometers per hour and slower boat will be x2 minus y kilometers per hour. Now let's look at the conditions. We have been given three conditions. We have three variables to find out. So if you are able to form the equations correctly, then we should be able to solve all the values x1, x2 and y. The first condition they have given that the faster boat covers the distance 1 point times as fast as the slower boat. That means speed will be 3 by 2 when we compare faster boat to slower boat. So x1 plus y divided by x2 plus y equals to 3 by 2. That is our first equation, which has a relation between x1, x2 and y. Our second equation is coming from upstream, where they said that distance from y to x is half the time as slower boat. That means speeds are now in the ratio 2:1. Time is 1 by 2. So speed will be 2 by 1. So we have our second equation there, and we have another condition which says that for every hour the slower boat lags behind the faster boat by 8 kilometers. So let us take for 1 hour, let us see what is the distance covered by the faster boat. That will be x1 plus y into 1. And what is the distance covered by the slower boat? X2 plus y into 8. And they told us that the distance difference between them equals to 8. So when we simplify, we will get x1 minus x2 equals to 8. Now this seems to be a little bit complicated, but if we apply componendo dividendo on our first two equations, we can easily solve this problem. Now what is componendo dividendo? If a by b equals to c by d, then a plus b by a minus b equals to c plus d by c minus d. Now let's apply componendo dividendo on the first condition. We will get x1 plus x2 plus 2y divided by x1 minus x2 equals to 3 plus 2 by 3 minus 2, that is 5 by 1. Similarly, second condition we will get x1 plus x2 minus 2y divided by x1 minus x2 equals to 2 plus 1 by 2 minus 1, that is 3 by 1. But we know x1 minus x2 is 8 kilometers per hour. If we substitute x1 minus x2 as 8 kilometers per hour, then we are getting a x1 plus x2 plus 2y equals to 8 into 5, 40. Because we know x1 minus x2 is 8 kilometers per hour. Similarly, from the second equation, we will get x1 plus x2 minus 2y equals to 24. Now, if you solve these two equations, easily you can see that we can get what is x1 plus x2 and what is also the value of y. Since we know x1 minus x2, we got x1 plus x2. Easily we can calculate all the values x1, x2 and y. Now x1 plus x2 plus 2y is 40 and x1 plus x2 minus 2y is 24. Let's add both of them. Now we will get 2 into x1 plus x2 equals to 64, or x1 plus x2 equals to 32. x1 plus x2 equals to 32 and x1 minus x2 equals to 8. Solving them, we will get x1 equals to 20 and x2 equals to 12 kilometers per hour. And also you can calculate the value of y also by substituting in any one of the equation, and you see that y equals to 4 kilometers per hour. x1 is 20 kilometers per hour, x2 is 12 kilometers per hour, and y equals to 4 kilometers per hour. Now the same problem you can solve it by looking at the options. Pick an option and you already know that x1 minus x2 equals to 8. So if you have suppose taken B option as correct and you took x1 as 20, then you know that x1 plus y is x1 is 20, then you know x2 is 12. So you can apply the conditions given and check whether it is satisfied, then you know that option B is correct. But that is objective way of doing it. If you want to do it subjective, this is the way how you have to do it. You have to get the conditions correct, then you have three conditions, three variables to be found out. So we can apply componendo dividendo and we can easily find out the values of x1, x2 and y. So that's one interesting example. I got it from some quantitative aptitude textbook, so I just thought I'll share that with you. So please do let me know if you have any easier solution or you have any feedback on this. Thanks for your time. Bye for now.